Hello everyone, I am Riddhi Suteri and today we are looking upon this problem, that is pairs of song with total duration divisible by 60. So here is the problem description. So the problem description says that you are given a list of songs where ith song has a duration of time I seconds, and this whole thing says that we have to find the total number of pairs wherein time I plus time j would be a number that is divisible by 60. I mean, that is exactly divisible by 60. Also, there is one more additional condition given, that I should be less than j. Right. To solidify this problem statement, there is one or two example test case given. Let's look at this. So you can see that these individual value represents the song timing, and we can find three pairs from here which can be added to get a number which is divisible by 60. So you can see that 30 can be added with 150 would result in 180, which is divisible by 60. Also 20 can be added up with this 100, which will result in 120, which is divisible by 60. And yeah, this 20 can be paired up with 40 to get a number 60, which is obviously divisible by 60, right? Also, there is one more example. If you want to look at it, you can pause the video and look at it. I'll explain it, by the way, and later in the video. So this is the whole thing. So now let's look at the intuitive solution, the brute force solution, and let's see what all time complexity does it have, and how can we improve it further. Okay, so the basic or intuitive solution that might come up to your mind is, okay, let's I have also copied this entire example array 1 here. So the first thing that might come up to your mind is, okay, let's take a yeah, let's take a pointer I. Let's fix it here. Let me take another color. So let's take a pointer I. Let's fix it at the very first position, and let's take another pointer, suppose j, and let's start this from I plus 1 position, right? And what we are trying to do here is, we are fixing I at the start of this array, and we are trying to look for its complement value in the rest of the array. So we will first of all look or add the values at I and jth index, and we will look if these values sums up to a number which is divisible by 60 or not. In the case, if the value matches to something that is divisible by 60, we will simply increment our counter, and if it is not the case, we will keep on incrementing the j value. Also in the earlier case, we will also increment j, by the way. So I'm not going to dry run all of this process, because this is very simple process, and this does not require that much of attention. So yeah, so after fixing all of these things, after running this loop for I fixed at 30, what we will do is, we will increment I from here to there to this 20, and we will repeat the same process again in here. So clearly, I think you all might have known that the time complexity of this process would be O n square, which is not a good time complexity. So let's see that if we can improve this time complexity or not. So also, before doing this, let us also look upon the constraints of this problem. So the first constraint says that the times length could range from 1, and it could go up to this much length. Also, the interesting fact here is that the times individual value, or the individual value that the array might contain can go up from 1, and maximum value of it could be 500. So what I am trying to do, or what I am trying to get from this, is that we have a limited set of values that could be in this index. I mean, that could be in any index. So what I am trying to say here is that I have taken the remainder of all of these individual values when divided with 60, and as I've already told you, that this will not make any difference. So what is the point of doing all of this calculation? So I'll explain this in a while, that why I've done this process. And there's one more thing that comes up to our mind at this stage. So suppose we have taken a remainder with 60, right? So what could be the range of the remainder that could go in these values? Obviously, the range of the remainder could go from 0 and the maximum value could be 59, right? I hope it is understandable at this stage. So since we have this range of the integer, and now what I am trying to do here is I am looking at these remainders values, and I can clearly see that some integer or some remainders might repeat. So now what I will do is I will map these remainders with their frequency, right? Like how many times 30 appears and how many times 20 appears, or if there are n such numbers, so how many times these numbers are occurring. So for this mapping wala part, what you can do is either you can take the inbuilt hash maps, or you can also take the help of the array as well. I mean, you can take a new array of size 60, and you can treat each index value as the remainder itself. I have made this simple array. Obviously, I have taken only 0, 10 and 20s, a few greater integers here. This will not be same in the memory, because there would be 1, 2, 3, 4, 5, 6, etc. There would be numbers in between here as well. After you have done this, what you will do is you will obviously all these values are initialized by 0, because we are trying to map their frequency. So suppose we find 30 in this, let me take another pen. So suppose if we find 30 in this, so what we'll do is we will reach at the 30th index of this frequency array. Let's name this array as frequency. So we will increment its value by 1, right? Then we will move on within our next value. So we'll reach out with the 20 and we will increment this counter by 1. Similarly, again, since we find 30, we will reach this index and we'll change the value by 2. Right? We will move on to the next value. We'll find that there would be 1 and similarly 40 again. So yeah, this would go like this. Right? I hope I filled all these values correctly. Okay. So now we have filled all of these values correctly. So what is our next step? What we are going to do next? I hope you are getting a little idea about what our next step could be. So we will be traversing upon this array, and first of all we will look upon these values. Suppose I find 20 in the array. So what I'll do is now I'll have to find its complement. I mean, its complement would be 40, because 40 when added with this will give a number 60, and we are looking for a number, we are looking for the pairs which will sum up to something that is divisible by 60. In this case, we are only looking for the numbers that will sum up to 60, because we have narrowed down all of these numbers and we have taken down their remainders in here. It's suppose I have 20 frequency. So what I will do is, suppose I write n of 20. N of 20 signifies the frequency of 20. So what I'll do is I'll multiply the frequency of 20. Sorry, this is 20. I'll multiply the frequency of 20 with its complement. Its complement would be number of 60 minus 20. After we, if we find any number, that is, this would be resulting in 40. If we find the frequency of 40 in the frequency array, we will multiply this value. Here you can see that the frequency of 20 is 1 and the frequency of 40 is 2. So this is multiply. Clearly this will result in 2 pair. 2 pair, which pair? 20 when paired up with 140 and 20 when paired up with next 40. Right. So we can make 2 pairs from these 2 values. Right. Similarly, we will move ahead with this 30 as well. Also, before discussing this 30, there is one special case. I mean, it is not that special, but yeah, since you have traversed this 20 and now you have looked out for its complement, what would happen if we traverse this more further and if we reach the 40? For 40, we will look out for its complement, and its complement will turn out to be 20. So again, we will count this pair. Again, we will count 20 with this 40, and again we will add 2 for this. So you can see that there is a duplicacy occurring here, which we don't want. So for this, I have a fix which we will discuss just in a while. So keep this in mind, that there could be a duplicacy issue which we have to handle. Also, now let's discuss this 30 case and this special 0 wala case, right? So in cases where we have the number 30 and 0, since 0 and 30 are their own complement. What I mean by own complement is 0 can be paired up with its own, if its frequency is more than 1, so 0 can be paired up with 0 itself, and it can form a number which is divisible by 60, right? And 30 can also form a pair with itself, which can result to 60, which suits for our answer, right? So for these two cases, we have to handle them very carefully. So by carefully, what I mean is, it's simple permutation combination, that if we have a number and if we want to pair it with itself, so number of combination that are possible in these cases are n times of n minus 1 by 2, right? So we have to keep in mind that for these two values we have to use this formula, not this formula, right? So I hope this 0 and 30 wala case is clear by now. So let's now look upon this problem that I was saying, that the duplicacy issue, and how we can eradicate this, right? So for this duplicacy issue, I have created this mini diagram for you. Now let's look at that, how this diagram could help us remove the duplicacy issue from our code. So you can see that what I have done is, I have this is the number line which represents our remainders from 0, and it can go up to 60. So what I have done is, I have, just a minute, I have divided this line into two parts. The partitioning part is at 30. So listen to this very carefully. This is very important thing. So what we are trying to do here is, suppose, let's take an example that we are at 10, and suppose 50 exists in our map as well. Suppose 50 also exists in our remainder array. So if we are at 10, we will look out for the its complement, that will be 50, and we will calculate the total number of ways possible by 10 and 50 by taking their pair, right? So when we have reached 10, we have calculated the possible ways by counting 10 and 50, right? Similarly, when we will reach at 20, we will count, or we will consider the 40's frequency as well. Now you can clearly see that if we go beyond this 30, what we are doing is, we will be allowing our duplicacy in our code. I hope you are getting this point. So clearly there is no point of going behind 30, because these value will be reused in this situation, and there would be duplicate values in here. So we will limit our search, or we will limit our this operation from 0 till 30, and in that part I have already told you that for 0 and 30 we have to manage them separately, right? So we will limit our search from 0 to 30 in the resultant operation. So this was the total operation that I've told. So the first step is taking this remainder array, and we have done this to narrow our search from 0 to 59 itself. Then we will make a frequency array, wherein we will mark all of these remainders with their frequency, and after that we have also discussed the special condition of 0 and 30, and after that, to handle duplicacy in our code, we will do is, we will narrow our search from 0 to 30 itself. Now I hope I've made this thing clear to you. So now let's look upon the code and let's see what I have done here. So with this loop, what I have done is, I have mapped all of these frequencies with their respective indexes, right? Then I have made this total count variable as 0, because I will be storing the final answer with here. Now now I will traverse this whole array, and for the special cases, what were the special cases? In case of 0 and 30, I will use this n into n minus 1 by 2 formula to calculate the total frequency, and for the rest of the cases, what I will do is, I will simply multiply the current frequency of this number and its complement, and I will add this into the total number. Also, one clear thing to note here is that we have only gone till 30. Why 30? Because I've already explained you this thing. And after we have completed this for loop, we will be having the total number of pairs in our total variable, and we'll simply return this total variable. So let me run this code and let's see if it passes the basic test cases or not. So you can see that it passes these test cases. Let's submit this now and let's see. Okay, so it got accepted. So that was the problem, and I hope you have enjoyed this explanation. So if you have enjoyed this explanation, you can consider subscribing to my channel. Also, you can like my video as well. Thank you guys.